In this video, we will solve the exponential growth problem that asks, what is the annual rate of growth? We will be finding a rate in this problem of an investment that grows from $50,000 to $1 million over the course of 30 years. This is an exponential growth problem, a compound interest problem specifically, and we will use the compound interest formula A of t equals a sub 0 times the quantity of 1 plus r to the power of t to find this rate of growth. Let's begin. The compound interest formula, again shown here, has four unknowns, four variables in this formula. The first one on the left side of the equation, a of t, it's actually a function with respect to time, and a of t can be thought of as the ending amount. In the case of an investment, the amount in the account after a certain period of time. A of t is the ending amount. A sub 0, on the other hand, is the amount after time 0 has passed, or the starting amount, the initial amount of the investment. In the exponent of the formula is t, which stands for time. We're looking for an annual rate of growth in this problem, so t will be measured in years. And finally, r in the compound interest formula stands for the rate of growth. It's a percentage written in decimal form. In this particular problem, we're considering an investment that grows from $50,000 to $1 million over 30 years, and that means the ending amount is $1 million. A of t is $1 million. How about the starting amount? Well, we can see by parsing the problem that the starting amount, the initial value of the investment, is $50,000. The time that is passing is 30 years. This investment grows from $50,000 to $1 million over 30 years. And the rate of growth is the unknown. The question is, what is the annual rate of growth? That's what we're trying to find. We have a value for the other three variables in the formula. The only one missing is the rate of growth. Substituting these values into the compound interest formula gives us 1 million equals 50,000 times the quantity of 1 plus r to the power of 30. Again, this is an equation with one unknown, r. If we solve this equation for r, that will be the annual rate of growth for this investment. The algebra to begin isolating this r is pretty straightforward. I have on the right side of the equation 50,000 times a quantity that's raised to the 30th power. The r is in the quantity. I'll first eliminate the 50,000 that's multiplied by the quantity, and that can be accomplished by simply dividing both sides of the equation by 50,000. 1 million divided by 50,000 is 20, and on the right side of the equation, 50,000 divided by 50,000 is 1. So on that side of the equation, we're just left with 1 plus r to the power of 30. We're starting to isolate r. Now r is inside of a quantity that's raised to the 30th power. So we're going to have to eliminate this power of 30 to isolate r next. And there's a couple ways to think about this. One way, anytime you have a quantity to a power in an equation and you want to eliminate that power, you can take the root of both sides of the equation. In this case, the 30th root of both sides of the equation will eliminate the 30th power on the right side of the equation. If this were a quantity to the second power, I think you would be more familiar with taking the square root of both sides, but it works for any power. If you have a quantity to the 30th power, that power can be eliminated by taking the 30th root of that quantity. Now, certainly to keep the equation balanced, you'll have to take the 30th root of the left side of the equation as well. In this case, the 30th root of 20. Accomplishing that same thing, and really doing the same operation but writing it a different way, is raising the power to its reciprocal. Taking the quantity 1 plus r to the 30th power and raising that entire quantity to the reciprocal power. The reciprocal of 30 is 1 over 30. If you raise 30 to the 1/30th power, this is a situation where you multiply the exponents. 30 times 1/30 is 1. So this will become 1 plus r to the first power. This process will eliminate the exponent on the quantity that 1 plus r is inside. If you raise the right side of the equation to the 1/30th power, you certainly have to raise the left side of the equation to the 1/30th power. Now, mathematically, a 30th root is the same thing as an exponent of 1 over 30. On the right and left side of the screen, we have two situations where we're doing the same thing basically, but writing it in a different way. And regardless of which way you approach this, you'll arrive at the same situation. The 30th root of 20, or 20 to the 1/30th power, is an irrational number that begins 1.10501, continues forever without terminating or repeating. And on the right side of the equation, whether you think of it as the 30th root of this quantity to the 30th power, or raising the 30th power to 1/30th, its reciprocal, either way, those are going to cancel each other out, the 30th root and the 30th power, the 30th power and the 1/30th power, and you'll be left with just 1 plus r. Either method accomplishes the same goal of eliminating the exponent on the quantity, and at this point, our equation is almost solved. 1.10501 and so on is equal to 1 plus r. One more step to solve this equation. All that's left to do is subtract 1 from both sides of the equation to isolate r. That results in 0.10501. Again, this is an irrational number on the left side of the equation, and it's the value of r. It's the annual rate of growth of this investment. It is a percent that is written in decimal form. So to write it as a percent, we'll move the decimal place 2 places to the right. I'll round it off to the nearest tenth of a percent. And that means that the rate of growth for this investment, again, from 50,000 to 1 million over 30 years, is about 10.5%. You can use the process described in this video for finding rate of growth if you know the other variables in the compound interest formula.